in this video we want to integrate x minus 2 over x squared plus x plus 2. We can apply two methods to integrate this problem, where we are having alteration of the numerator as our first method. Then the second method is U-substitution. So let's look at the first method. When we do this method, it takes a little bit of imagination. Firstly, I will differentiate the denominator. So I will let my denominator to be f of x. Then I will have f of x is equal to x squared plus x plus 2. So now I differentiate it. I get 2x plus 1. So from here, what I need to do is to find two numbers that when I add, they should take me back to -2. So, and also within those two numbers, one should guide me back to this differentiation here. So I can see that if I imagine that this is like this now, if I can add a 2, because I can see that here I only have an x, this is going to be 2x plus 1. So, okay, what is happening now? I have 2x plus 1 there, meaning that now I need the second number that when I add it, it should give me -2. So I will have a half. This number I can call it b, and they should give me -2. So now I have to solve for that number, which is going to be -2 minus a half. Then b is equal to -5/2. Then indeed 1/2 minus half, it's actually equal to -2. So from here I can rewrite this integral as a half minus 5/2 all over x squared plus x plus 2 dx. Then from this step I can split it into two parts. Then I will have x plus a half all over x squared plus x plus 2 dx is there, and then 5/2 dx over x squared plus x plus 2. So what is happening now? Now I can try to take this one back here. Then I will introduce a 2. Then it's going to be 2x, or let me just put the 2 there. Then I will have it as it was. Because I put the 2, I must divide by 1/2. Then I have dx here. Then I have x squared plus x plus 2 minus 5/2. Then dx over x squared plus x plus 2. Then from here I can see that if I multiply the brackets by that 2, I will get 2x plus 1 over x squared plus x plus 2 dx minus 5/2 dx over x squared plus x plus 2. Then here I can see that this I can integrate by this formula. Dx, which gives ln of f of x plus c. Let's let's remove this. What's happening now? Okay, and then this side, what can we do? We will complete square. We can complete the square on the denominator. So when we complete square, we have to remember that we divide the middle term, the coefficient of the middle term, by 2 and square it. Then plus 2 is still there. Then we can subtract by the coefficient of the middle term squared. Then this is going to be x squared plus x plus 1 over 4. This we can keep this side. And then plus 2 minus 1 over 4. Then this end up being 1 over 2 all square plus 7 over 4. So we have completed square on the right hand side. So what do we need to do now? We need to go and proceed and rewrite our integrals in a new format. So we had 1 over 2 integral of 2x plus 1 over x squared plus x plus 2 dx minus 5 over 2 into dx. Then this side, we said that we can complete the square, then it can be like this. The reason we are completing the square on the right hand side, we can see that we can use arctan that side, and then on the left hand side we can integrate by length. So before we use the arctan, we can rewrite that again. Then we have 2x plus 1 over x squared plus x plus 2 minus 5 over 2 to dx over 1 over 2 square plus, this can be rewritten like this, all square. So we can see that now here we can use arctan, because the formula for arctan is in this format, plus a square, which is equal to 1 over a arctan f of x over a plus c. So we can see that now our a is actually square root of 7 over 2. Then our f of x is actually x plus 1 over 2. Then this side, on the left hand side, we can say we can use ln, because we can see that the differentiation of the denominator gives exactly 2x plus 1. So we can just use the ln. Then we have minus 5 over 2. So there I can see that I have to multiply by 1 over a, but instead of multiplying by 1 over a, I can divide by a, which is going to be actually 2 over 7. Then arctan f of x, my f of x is actually x plus 1 over 2. Then this is divided by square root of 7. So let me do it like this. So it's actually square root of 7 over 2, then plus c. So I can see this 2 and this 1 will cancel. Then I end up having 1 over 2 ln of x squared plus x plus 2. Then I'll have minus 5 over square root 7. Then from here, I'm just simplifying. So I can see that here, I can end up having 2x plus 1 over 2. Then I flip this by changing the sign. I'll have 2 over square root of 7, then plus c. This 2 and this 1 will cancel. Then I will end up having 1 over 2 ln x squared plus x plus 2 minus 5 over square root of 7 arctan, then 2x plus 1 over square root of 7 plus c. So we have successfully used the method of alteration of the numerator to integrate. So let's see how can we use U-substitution for the same problem. So the problem was x minus 2 over x squared plus x plus 2 dx. Now we want to use U-substitution. So how do we do this? We do this by first splitting it into 2. Then we have x over x squared plus x plus 2 dx minus 2. We can take it out of the integral because it's a constant. Then we have x squared plus x plus 2. We have just divided x minus 2 by the denominator. Then from here, we can complete the square. We have already completed the square on the denominator. So we found that it was x plus 1 over 2 plus 7 over 4. Then let's have dx here. Then we'll have dx. We complete the square on both sides now. So then from here, we can see that this term again, we can integrate by completing the square. It's going to be the same thing as we did here. But now the problem is that it's this side on the first term. So we can apply U-substituting on the first term. If we say that u is equal to x plus 1 over 2. So I let the x to be equal to that only on the first term. Then I end up having, or before I continue there, I will see that if I solve for x will be actually equal to u minus half. Then wherever I see x, I must substitute u minus half. So I have u minus half. Then on the denominator, I can actually have u squared plus 7 over 4. Now this should be du, because I'm actually now working with integration of u. I changed everything to be u. Then this side, I said we can leave it as it was, because this we can actually solve the integral for this by using arctan. Then we can split this term here into 2. Then when we do that, we get that u over u squared plus 7 over 4 du minus 1 over 2 integral of du u square plus 7 over 4 minus 2 dx x plus 1 over 2 plus 7 over 4. So what are we having here now? We can see that this now is doable by a ln. This now is doable by arctan, and then this is also doable by arctan. So, but firstly, what I can do is to leave this one with u's. So this side I must keep the u, or I can put the 2 here and divide by 2 there. Then this side I can have 1 over 2. If I change this now to be in terms of x, it's actually going to be just because u is equal to x plus 1 over 2. Now it's equal to that plus 7 over 4 minus 2 into dx over x plus 1 over 2 all square plus 7 over 4. So I can see that these are like terms. They have a lot in common. So I can see negative half and minus 2. They give me negative 5 over 2. Then this one, I can rewrite it as 2u du u square plus 7 over 4, then minus 5 over 2 of dx over 7 over 4. So now when I integrate, I'll get that this is equal to 1 over u ln u minus 5 over 2. Then this one we have already found its integral this side, which is actually going to be here. It's going to be 2 over square root of 7 arctan into 2x over the square root of 7. We have already solved this. We don't want to waste a lot of pages. It is the same thing that we're having this side. So this 2 and this 2. Then we have 1 over 2 ln u minus 5 over square root 7. Then arctan 2x plus 1 over square root 7 plus c. Then we know that u is equal to x plus half. So we'll have u 1 over 2 is equal to ln of let's see what we are having here. Oh, sorry, this is not actually, this is not ln u, it's ln u square plus 7 over 4. Sorry for that. Even here we're having u square plus 7 over 4. So we can see that this should actually take us back to x square plus x plus 2, because it's what we completed the square that on the other side. Then we'll have 5 arctan 2x plus 1 over square root of 7 plus c. So that's it. You can go and look at these two methods and see which one works for you. Until next time, thank you. Please like this video and subscribe, and please let me know if there's something that I've done wrong on the comment section. Thank you.